Thermal expansion and contraction. Paragraph 301.7 cautions that the thermal effects must be taken into consideration for piping systems so as to not restrict the expansion-contraction with restraints or anchors. Piping must be evaluated for expansion and contraction by the use of Appendix C of B31.3. Appendix Table C1 lists the thermal coefficients needed to calculate the linear expansion or contraction, and following are some simplified examples of these type calculations. Here's Table C1, thermal expansion data. In the header we see that the capital A means the coefficient of thermal expansion. Capital B equals linear thermal expansion in inches per 100 feet of piping. We'll be using B. A is used when you want to calculate by hand the expansion in fractional parts of feet or some other method, but we'll work strictly with the B, the linear thermal expansion in inches per 100 feet. Makes it simple. Blocked in red you see a column, and at the top is 70. That's 70 degrees F. This is considered to be the zero or neutral point where the piping is neither expanded or contracted. So all figures start from there. Next we see the rows, various materials. Material column, group 1, carbon and low alloy, group 2, low alloy, 5 chrome, 1 moly, etc. down the column. We'll be using this table for all the exercises to come. Example problem 1. Find the linear thermal expansion in inches per 100 feet as the temperature rises from 70 F to 400 F for group number 1 carbon and low alloy steel piping. From the table C1, the piping will expand 2.8 inches per 100 feet. Table C1. On the left, under material, we see the group 1 carbon and low alloy steels. To the right, we see 70 blocked in red, the neutral point. To the right of that, we see 400 blocked in red, the target temperature, or operating temperature if you prefer. Beneath that column, blocked in red, we see 2.8, as indicated in the previous answer. 2.8 inches of expansion from 70 to 400 degrees F. Example problem 2. What is the total thermal expansion in inches for a 500 feet run of austenitic stainless steel 304 if the temperature will range from 70 degrees F to 500 F? From table C1, the piping will expand 5 inches per 100 feet. Therefore, 5 units times 5 inches of 100 feet equals 25 inches. Table C1. Blocked in red, we have austenitic stainless steels 304, 305, etc. From the 70 degree F column to the 500 degree column, we see 5 inches of expansion per 100 feet. 5 units times 5 inches, 25 inches. Example problem 3. What's the total thermal contraction in inches for a 300 feet run of an austenitic stainless steel if the temperature will range from 70 F to minus 150 F? From table C1, the piping will contract negative 2.1 inches per 100 feet. Therefore, negative 2.1 inches times 3 units of 100 equals negative 6.3, or a total absolute contraction of 6.3 inches in 300 feet. The piping, if measured cold, would be 300 feet minus 6.3 inches. From table C1, at 70 F down to minus 150, we see that the austenitic stainless steels would contract negative 2.1 inch per 100 feet. How can we calculate uneven values like 115 or 217.5 feet? And since the standard unit for calculations are units of 100, same approach as metric, this becomes a simple task. The 115 would be divided by 100, which would equal 1.15 units times the value given in table C1. Likewise, 217.5 divided by 100 would be 2.175 times the value given in table C1. Simple.